All right, go.
Okay, so we are presenting, unveiling, and open sourcing a new linear cache, a caching proxy for traffic control. I think it's kind of a poorly kept secret at this point that we've been working on this. Some of you may have noticed my commits to open source kind of dropped off about 9 months ago. This is what I've been working on. This has been most of my work for the last 9 months at Comcast, and a few other people. Jan did some work on it, and John Rushford. So it is a new, primarily linear cache. The code name has been Grove. We're totally open to renaming it. Again, I have very little opinion on the name. That's just the working title. A little bit about this cache. Again, it's a caching proxy like Apache Traffic Server. It's written entirely in Go. It has very few dependencies. I don't know if anybody else cares about, like, people talk about zero dependency stuff. It's actually got two dependencies right now. One is the SIP hash. It's the same hash ATS uses, and the other is what's the other one? It's a prototype disk cache that we're using a third party for the file. But yeah, it's very few dependencies written entirely in Go. 6,000 lines of code. So one of the primary goals of this is something that is easy for us to develop on. You know, Apache Traffic Server is great. The things it does, especially the disk, is something we'll probably never exceed the performance of, but it's 400,000 something lines. It's a lot of work to develop. It's C. It's just a lot to work with that much code. This is literally 6,000 lines of code. It's RFC 7234 compliant, which is the HTTP caching RFC. And it does have a configuration to disable strict interpretation of that for safety, because strict interpretation requires accepting no cache headers from the client, and obviously that can destroy origins, kind of defeats the purpose of a CDN. So it's compliant and you can disable it, and you probably will if you're running a CDN.
Rob, can you say how crazy that is at 6,000 lines?
Yeah.
ORT is 3,000 lines.
Yeah, it's great.
ORT.
And of course, I mean, a lot of that comes from a high-level language. You know, you don't have to deal with memory management like C++. But at the same time, Go's pretty vertically verbose. So even that is kind of I think it's a pretty small number. And so it's great. It's that much less to work with. It's so much easier to develop on just because it's less code. So it has a compile time plugin system, and I'm going to spend a little bit of time talking about that because I think that's one of the big benefits of this. It is robust, it is flexible, and if this doesn't do something you need to do, you can write a plugin for it. And again, I'll talk about that in a bit. It's high performance, so performance is a goal. We're a CDN, it matters. We have tested this saturating 20 gigabits, and that is specifically with some tools we have to replicate our production traffic multiple times as much as we want. So we have been able to saturate a 20 gig NIC with this. We're planning on testing it with even more, maybe with 100 gig NICs. But if you're worried about performance, we've tested it and we can saturate 20 gigs. It has an LRU memory cache. So the cache itself, the memory cache of objects is extensible. It's an interface in Go, so it's fairly easy to plug in and plug out. But the current one we're shipping it with is just a basic LRU memory cache. It works well for the CDN. It works well for linear traffic. Again, you could replace that. It'd be fairly simple if you have other needs. It's not currently part of the plugin system, but I think it probably should be at some point to make it more pluggable. On-the-fly config reloading, it's just another feature it has. You can change the configuration. You can change the application configuration itself or the remap rules. What we call delivery service is what ATS calls remap rules. You can change them on the fly and do a service reload. And the way it works in the code is it will create a completely new HTTP server for all that serving, and then it will atomically swap the pointers. So you don't drop any traffic. You're still serving, and you're able to reload the remap. The cache is ATS compatible. That's a really big deal for us. It's probably a big deal for anybody that has a lot of traffic, like a CDN, and is running Apache Traffic Server and wants to deploy this concurrently. The caching, again, it's SIP hash. It's the same consistent hash that ATS uses, and what that means is for your consistent hashing for both the cache, and we're actually using the same hash to the mid-tier, to parents. And again, what that means is it's compatible with ATS. You've got mid-tiers, and you map to the same mid-tiers so that you don't get cache invalidations and destroy your mid, destroy your origin. Has an RPM, has a Docker file, and it has a config generator for traffic control. So it's got an app that's kind of like ORT. It's just called Grove TC CFG, but it generates the config for this. You can run it in a cron job just like ORT. So kind of another side goal of this has been to be as similar to ATS and ORT deployments as possible, just because that's what we do. So it's easier if we can make it similar so ops doesn't have to learn a lot more. Again, this works very similar. The config generator uses native APIs, so that's kind of one of our goals for ORT in the future, and one of our goals for traffic control is to be cache agnostic. This does that with Grove. Its config generator uses native APIs to get the CR config and the other APIs that in ORT are generated on the traffic control side, on the traffic ops side. This does it natively with native APIs. It's completely decoupled. Again, it's just like ORT. And we are running this in production at Comcast. So again, if you have questions about is this feasible, is it done, does it have a lot of work to do, we are running it in production. Again, we've got Docker files and RPMs, and we've tested it to high performance. This works. This is essentially finished, and we're in the process of rolling it out.
Rob,
yes.
Could you say a little bit about what your motivation for building Grove was, like where traffic server didn't work well enough that motivated?
Yeah. So again, the primary motivation I would say is just speed of development. It's just a lot of time. Anytime you need to dive into ATS to fix stuff, especially to fix bugs. There are bugs that nobody's been able to fix in ATS that we've spent countless man hours. Other people have spent hours, and just deep in in the engine, and it's just a lot of development. And so this gives us something that is, again, it's 6,000 lines. If we need a new feature, you can write Go, you can write a plugin that's a couple hundred lines and have it out in a matter of days as opposed to a matter of months. That was one of probably the biggest motivator. Yeah, it's
also the stability side of it. We've been struggling to get around all of the memory leaks and site faults and all of that BS that comes with the C++ application. And we've been dealing with that since I've been on this team, so almost 5 years, and that shit gets old.
Yeah, we have ATS restart all the time, and this. Again, it's 6,000 lines. We've had bugs, but it takes days to fix as opposed to months.
And I also feel like the ATS, you name any caching software that's out there right now, was built for something else than what this is. This was purposefully built to do linear TV distribution. That's what we're focusing on. That's what we want to solve, and I think that's a different problem than distributing web objects to a browser.
In the 90s.
It's a different in the 90s. It's a different use case. It's a different problem. It's a different. I think that those are the most important things.
What's the improvement over ATS linear serving with this?
You mean like performance?
Yeah,
Well, we're not CPU bound, so we can saturate the NICs. So the performance I would say is the same. If you're asking for like TTMS, like the time to serve. I don't think there's an appreciable difference. Again, most of that, if you're more than like a kilobyte, that time is going to be just network. So I would say it performs the same, which is the goal.
What would you say this does less well than ATS?
Number one, disk. So again, the goal of this is linear. It does not have it does not have a tested disk cache. It has a prototype that we're not using that I wrote in a weekend, and I'll get to that in a minute. But disk, so ATS has that cyclone buffer. It's probably the fastest thing that we're ever going to see on a magnetic spinning disk. That doesn't exist for Go. We could spend a year writing it, but I don't know that there's a value in that when we can just use ATS. So yeah, the number one is it doesn't do disk. Again, it's got a prototype. I'll talk about it in a minute, but there's no way it performs as well as the cyclone buffer. So and we don't plan on using it for VOD.
So this will be, my understanding of it has always been this will be a third CDN for
No, it's gonna be, they can participate just like any cache.
Yeah.
And in fact, we're using it as deep caches as well.
Yeah,
But
so
it's
the
strictly for linear, I mean, we're not targeting anything else for these, at least not at this time.
yeah, the plan is
These
to
are
use
the
for deep a lot because again, it's more lightweight. It's less code, so I don't know if that matters for deep, but deep linear, and again alongside. So that's the whole ATS compatibility thing. So the caching and the mid consistent hash lookup is all ATS compatible, so that we don't break our cache on the same CDN.
Can these functions reverse and forward?
I believe it might. We're only using it as reverse now. It'll be easy to add forward if it doesn't. It's
I don't think we should. Don't see a use case for it, I don't think we
So-
should. One of the things we really, I think,
but maybe we don't. Maybe Cox does or somebody else. Who knows?
but I think one of the good things, this is how you get to 400,000 lines of C++. Oh, let's put this.
Well,
feature,
and that's
let's put
part
that
of the
feature.
plugin
We
stuff.
need to keep this
So-
thing as lean and mean as we can.
And I agree, and that's a lot of the motivation for the plugins as well, is so that when we want something that is specific to us, we don't have to add it to the code. When somebody else wants something that only they will ever use, you can write a plugin, and it's not part of the main code. You know, hopefully we can keep that main code base really small and flexible.
So do you have somewhere comparison of like, let's say all the ATS features or all the delivery service features that you can turn on, and that we probably do turn on in linear delivery services like
I don't,
and
but
MSO and all that
right now the answer for most of those is that it doesn't do it. So it has a few things. I mean, obviously basic remap rules. We added plugins for header rewrites. But most of those things don't exist yet. Again, this is like step 0. We're just now rolling it out. As we need more things and we say, you know, we want to assign this delivery service that does this thing, then we'll add a plugin for that.
So do I guess the main one I'm wondering about is rewall writing.
You think it does?
Yeah, you have the waiter stuff, right?
So, yeah, and I should have had a slide on this. So that's a little bit more complex. So it doesn't do read while writings that while it's reading from the parent, it writes out at the same time. You know, it's say you've got a gigabyte file, you start writing as soon as you're reading. It doesn't do that. I think we can add it. It just hasn't been a priority for us, and it might be difficult. It might not.
Okay, because you said something about compliance to protect origins.
Yes.
That's kind of part of this, or
Is that what?
So it does do the only. It's very strict at only doing one request to the origin, or even though you
Yeah,
have
so-
6,000 people asking
so-
for the same thing.
Yeah. So
It's
that's
very good at that, but it doesn't do. If it hasn't received the whole thing, it won't start sending.
yeah.
to
So
the
that's
6,000 waiters yet.
That's what I'm trying to say, is to directly answer your question for read while writing. It doesn't start sending while it's receiving, but it does have solid stuff to protect the origin. So what Jan said a minute ago about thread stuff and sending out multiple things. So the way it works is there are throttlers in place. They're just called throttlers in the code. I don't know what else to call them. That it's an object that you get a request in, and then we forward it to this thing, and that throttler is configurable for the entire parent, the entire origin, or the delivery service, and the URL itself for that particular cache key to say how many you want to let through. And 1 is a completely reasonable number. And so if you configure that to 1, you get 100 requests or 1,000,000 requests all at once. And what happens is they all hit that throttler, and in the code, all those connections are waiting for that throttler, and it will make a single request to the parent, get that back, and give that to everyone, assuming it's cacheable. Obviously, if it's not cacheable, we figure that out, and we'll make another request. And there's an additional throttler level that if you get something that's not cacheable, you can say, well, let 10,000 through at once, or something. But yeah, we have those levels of throttlers that it's a hard limit. There's no ambiguity. I know in ATS we've had a lot of issues with lots of things getting through when they shouldn't. This is a hard limit. It hits that throttler. It's in Go. It's all Go routines and channels, and it'll only let through as many as you've let. And it can be 1, it can be 100, some small number.
all right, you're not having to complete the request before sending it, because it seems like, well, this might be performance, like difference between ATS and.
Yes, and that hasn't been a priority for linear.
Again,
Most
because of the use case we're targeting, right?
Yeah, for
We're
linear-
looking for linear DB distribution, fragmented IV.
Yeah,
So
it's all
I mean,
TS
is
files.
that
They're
really a-
2 seconds.
yeah.
Yeah.
I mean, I guess
We're not
the
going to be
files are that
doing big
but-
files.
And so in terms of the code, I don't know if you're familiar how much you work with Go. So in Go has streams just like C++, and I think we might be able to match up streams that we get in a request and then start writing that and do it as a read while writer, but we haven't looked into it. It's probably either easy or really, really hard because at the high level, Go gives you high level stuff and it can be harder to get under that.
Byte ranges, to handle all that stuff.
Range requests?
Yeah.
No. So range request is another thing on the feature list. I think it would be great. It could be
It
easy or
currently
it could be
handles
hard.
the Roku case well, though. So what happens in Roku? We did put in a plugin where it says, range is this, and we say, screw you, here's 200 okay with the whole thing, and that works.
So, I guess, I am a little worried that down the road, like maybe we switch to a single file that's not fragmented and we just do byte ranges.
And I agree. And range request is something I would really like to add to this. I think
Yeah.
it would add a lot of value.
Yeah, I think step one is not going to be that hard.
Yeah,
I think that's going to be.
doing it well is hard. Doing
Yeah.
it quickly is hopefully not.
What is the comparison of hardware deployment needs? Is that exactly like ATS?
Yeah, again, it's not using disk, but everything else is just the same. It's however much
Yeah.
memory you want to give it, you put that on your box.
I hope though that this will outperform ATS fairly significantly
Right.
in the future, right? I think we should be targeting 100 gig machines. We should be, I think these EL4000 cartridges with 100 gig, we should be trying to get to like 80 gig or something on those boxes.
So when I was just thinking about with heat caching, maybe you could have a lesser
Yeah,
piece of hardware.
which
and then
which
maybe-
is exactly what the EL4000 is, right? Those cartridges have like tiny little CPUs and they're not as beefy at all as the Dells.
I believe your memory, actually your memory about
Yeah.
I'm sorry, what?
the main.
Yeah,
the
physical
main-
memory.
yeah, this is the main.
Yeah, and it uses main memory, so it uses ordinary memory. It's a map in Go. It's not doing block devices or anything like ATS
But
for the
in
memory.
the future, maybe we do. I mean, right now you've got the file-based disk storage.
Right.
Yeah.
Maybe in the future we can do a cycling buffer like thing. Grow.
Yeah. Again, if we want to spend a year or so developing, maybe it's worth it at some point.
I don't think we need to do a year developing. I think we can, take a couple of
Maybe.
SSDs and just smash it with performance of SSDs, and if that doesn't work, then we rip out the disk though.
Yeah, and I tend to agree. I think things are moving towards SSDs, and I suspect the disk it has, and I'll talk about it in a minute. I suspect the prototype I put in might even outperform ATS on SSDs. It might,
So,
it might not, but again, SSDs are just so
I
much
think
better
it'll
with
be fast
random
enough for
reads.
the use case that we'll give it.
Yeah.
That's what we're looking for, right?
Yeah, so just a brief overview of the code again to give you an idea of it's 6,000 lines. It's like 79 files, maybe 60 files of code. This is it. I mean, this is every file in it. This is the code, and none of them are terribly big.
So just for reference here, one of our hosts in production right now is using 80 gigs of memory out of 128 on 1 diesel and 510 cartridges and about 4,000. So it's just a little. We've got 4 cartridges per chassis.
You mean with Grove?
So,
You mean a Grove?
Yeah.
Yeah, and that's just how much we gave it. We could give it a little bit more.
How much can you give it?
As much as the box has. So it's a little bit complex because we're not counting header bytes, and that's kind of complicated. So the amount that we store is a little bit higher. I mean, there's a cap on the headers for safety, right? For DDoS attacks, but it's kind of expensive to count those in Go. So it's more of a soft limit, and it's also a soft limit because the way the LRU works is a little bit flexible as well. We can get better performance and do less work. Again, when you're trying to saturate that 20 gig NIC, we can do a little bit less work if we're okay with having a soft cap. We could put that hard cap in, but right now it's soft, so we just give it 80 when we've got 120. But if you need a hard cap, it wouldn't be hard to add. So again, just looking at an overview of the code base, you can see again it's 5,900 lines of Go and some other stuff, but that is it. It's literally 6,000 lines of code. So like I said in the beginning, I'd like to talk more about plugins and hopefully do a really brief tutorial of how to make a plugin, because it's really easy. And again, I'm hoping most of our future development can be in plugins. I think we need to put more stuff in plugins, stuff that's currently in the main code, I think, can even be moved to plugins. And we need to add more hooks to plugins and more data. We've just added what we've needed, but I think we should add, a dozen more hooks for calling plugins and pass more data, so that, again, every new thing we do just about can be in plugins rather than kind of polluting that main code base. So what I'm calling a plugin system, they're native code, and just to give credit, this was originally a suggestion by Chris Lemons. I don't know how many of you met him. He's a newer guy on our team. So what we're calling plugins are compile time plugins. It's a native Go file. Again, it's compile time. It's built when you build it in native speed, so you're not having to call a Lua engine or a scripting engine or even a shared library. It's pure native, and they're independent files. So it's a completely isolated file that doesn't touch anything else. And the huge benefit for that, I think, is that it allows us to have proprietary things. We can have a file at Comcast that is specific to us, that we can't open source or nobody would ever want to open source. And at Cisco or Cox or whoever else can have your plugins, and you can have that fork or even maintain them somewhere else and put them in your build later. But you could even just make a fork of traffic control of Grove with these plugins, and you'll never get merge conflicts. I think that's kind of it's an easy thing to miss seeing this plugin system, but the way it's done with everything is independent means you can have that fork. And I think most of us have maintained a fork and known how painful it is to merge everything in. This should be conflict-free to do that and have your own plugins. Disadvantages of the way the plugin system works: there is no runtime modification. It's not Lua. It's not JavaScript. You do have to recompile and or redeploy. I think these are worth it. If somebody really, really needs to modify stuff at runtime, we could look into adding that, but that just comes at such a high cost. What does Lua add to our requests? We've done measurements, and it adds like 50 milliseconds or something just to 40 just to start that engine. So I tend to think it's safer. Things are compiled, and it's faster.
And just to be clear, if you compiled in like the mod header rewrite stuff, you can add or modify how it works. You can change the configuration of a plugin.
Right.
If you didn't compile it in, you can't use it in your configuration.
Right, and I'll get to that in a minute. Yeah, so plugins have configuration. So anything you can make configurable, you can make configurable in the plugin, and hopefully, again, not need to redeploy.
I would argue too that with what this is for, it's mostly internal customers. We're not going to have the crazy requests that we get. For external,
Yeah.
customers, so we're not going to need to. They could do different stuff nearly as much.
Hopefully,
Well,
no.
and if we
Hopefully
do,
won't need
again-
as many plugins and that type of stuff, right? We just want to do
Well,
one thing really well, really fast.
Yeah.
Just to give an overview, these are the plugins we have today. These are just what we happen to need. Again, this is just an overview of what it can do. We have an ATS log plugin. That is what is doing the logging, and it's doing it in the ATS format /squid, just to be compatible, just so it can go into our Splunk without any changes. And that's done with the plugin. HTTP stats, again, is astats. It's serving an endpoint, just like astats, and it's a plugin. We needed a garbage collector just for some debugging stuff I was doing. I wanted to be able to call the Golang garbage collector on an endpoint, and so I wrote a plugin. If modified sense, again, that's one that we do have. It's just like if modified sense. Oh, I'm sorry. It's if modified sense is for client requests. So if a client is making a 304, if modified sense is a plugin that will intercept that and serve them the 304 as opposed to the full body. Modify headers. That's one that we do have. That's again just like ATS mod headers. You can mod. We have a separate plugin right now, modify parent request headers. We've extended the plugin system a little bit since that. I think we can merge those at some point. But it's just like mod headers from ATS. You can modify request headers, you can modify response headers. and record stats is what is actually recording the internal stats that are later served by HTTP stats. And that could have been part of the main app, but again, we're just trying to break things out into that plugin system. So yeah, those are what we have today, just to give a kind of a broad overview of what it's capable of. So again, I'd like to give a brief tutorial on how to create plugins, because I think it's really easy. So there's a single file. This is it, most of it. This is the stuff you need to know, and there's like a bunch of these. Like there's load, startup, on request, before parent request, before respond, after respond. Those are all of the hooks that we have right now. Again, I think we should add a couple dozen more. Those are just what we needed now. They're fairly easy to add. You just call the function in the main code. It's 200 lines. It's a single file, plugin.go, 200 lines, and that is our framework. And the way it works is you have an add plugin function. You call add plugin in your function in an init. Right, so that's how we do it in a single file. Is we're adding it to a variable on startup in the init function, which gets called on startup with Go. There's a funcs type that, again, you register with all of the hooks your plugin handles. And here's an example of one of those hooks is the onRequest func. That is a function, you write that function for your plugin, and then you call add plugin and register it. And that function will be called on the hook for your plugin with the configuration. That iconfig interface is the configuration that it gets from the remap file, and with the request data. And again, this is an example of the data that will be given. We should add more to that. There is more in that. I kind of cut it off with a slide. But that's an example of the system. So that's really all there is to it. Is you make your function that has the signature of the hook. You make it take in the data, do whatever it needs to do with the data, and you call add plugin in init. So this is a plugin. This is it. This is the entire record stats plugin. Like, that's literally how simple it is. So you make an init function that, again, gets called when the program starts automatically by Go. You call add plugin. You give it a priority. Priority doesn't matter for any of our plugins now, but it might in the future. So you can say, I need this plugin to be called before this one. And you create a funcs object that's kind of awkwardly in the middle there. You create a funcs object and pass it your function. It's passing record stats, you can see, as passing the function as a variable into the add plugin. And then your plugin does what it needs to do. For this, it's just writing stats. That's all there is to it, to writing a plugin. And you put these files in the plugin directory, and they're automatically compiled in. So the stats is kind of a Hello World plugin. Just shows you how easy it is. It's like 5 lines. This is a HelloContext plugin I made to give you an idea of how to pass data between hooks. So you might say, I have a start hook in my plugin and an after respond, and I need to initialize some data when I start my plugin up, and then pass that when it gets called, every time it's called. And that data can be anything. It can be a Go routine, to doing stuff in the background, whatever you need to do. And again, not just start, maybe you have a before respond and you need to calculate some data and pass that to the after respond. This is how you do it. So we have a context object, and every data object has a context object. And you can set that. It's an empty interface in Go, which is kind of like a void star in C if you're not familiar with Go. You set that to whatever your data needs to be. And then in the later function, you can call the data.context, and it will get that data that was called for, if it's anything but start, it will be that data for that request. So you've got a million requests at once. The contexts aren't shared. That would obviously not work. You'd have all kinds of thread safety issues. So the only thing that's shared is startup, because that's called before any request. And you do have to be aware of that the start data you set will be shared with everything else, but all the others are not. They're copied and have their own unique context. So that's how you pass data between hooks. If you have all your dozen hooks for a single plugin and want to do stuff and manipulate the request as it flows through, you can pass data for that through. This is an example of configuration. So again, your plugin can have configuration. If we start down here in the lower right, there's an example of the rules file. So Grove has two config files. It has the main application config, and then it has the remap rules. They're just like ATS's remap files, but it's JSON. In the rules file, for every single individual remap rule, you can make a plugins key that has the name of your plugin, and the name of your plugin is implicitly the file name. So we had that modheaders.go. This is an example of a modheaders config for this remap rule, and it can take any arbitrary JSON. And the way it's loaded is when you register your plugin, one of those hooks that you register is the load function that takes, if you look here in the middle left, the JSON raw message. In Go, that's an alias for a byte array, but it's designed to be passed to JSON.unmarshal, and you can unmarshal into any object. So you can have any configuration sub-object, any valid JSON in that plugin's config for that rule, for whatever your plugin needs to take, and then you register your load function, you unmarshal it, and you return it from the unmarshaled function, and that's that iconfig that you saw earlier. And that's, you can see here in mod headers, it's passed to the hook, and we get that out. And if it's nil, there's no config, nobody set a config for mod headers for that rule, and we just return. Otherwise, we try to cast it to the mod headers object that we previously unmarshaled it into. And again, that can be any object. It takes a JSON raw message, and the way that works under the hood is we defer processing. Go has a way you can defer processing JSON until later. So we process the config, and then we defer processing to all the plugins that have registered hooks for their sub-objects. And here on the upper right, you can see what the mod headers looks like. And so you can see in JSON, it's the set, the drop, and their arrays, and the header array of set is a name and value, and that's exactly what we have in the rules that got unmarshaled. So that's how you do configuration with plugins. Yeah, that's about it. Does anybody have questions about writing plugins? It's pretty simple, I hope.
Something very technical. The priority.
Yes.
You might want to know enums or something like that.
Well, you could for your plugin, but maybe someone else has plugins that might conflict with yours, and so you might need to be aware that they have.
Yeah, but enum with STD, for example, and maybe we want to have some kind of. I just don't like constant numbers in the code.
Yeah, I think it would be fine to define those,
Yep.
but the reason it's a number is just to give you more flexibility. You know, if you make an enum with 10 values, maybe someone needs 11
No,
priorities.
not really enum, but the constant.
Yeah, no, that would be absolutely fine. All of the plugins we have in the code now are just 10,000. That's just, again, because it didn't matter for our stuff. I would be fine with having a default priority or something.
And you wouldn't like to, you cannot actually search and replace later on because you don't know if somebody wrote plugins that is not taken.
Sure, and again, you don't know who will be writing what plugins in the future. So
How do I enable or disable a plugin?
you comment out the add plugin hook. So right now, that's the only way. You could disable it with the config. So you could say if there's a nil
But
config.
what if I didn't want to compile it in? I think we need a cleaner way of saying, I want these 5, because in the future, we hopefully will have dozens, if not hundreds of plugins, right?
Sure.
And you probably don't want to compile all of them in because they may do something that you don't want, or maybe there's 2 that actually are conflicting, that do the same thing in a different way or something like that. I think we need a better way of saying, I want these 5 plugins in this build.
Yeah, and we could talk about that. I mean, it's all compiled in Go, so there's not really a way to make the file not compile unless you renamed it something that doesn't start with Go. So you could rename the file, or you could comment out that add plugin, or in the code you could add a Boolean, some kind of array somewhere that checks, you know, here's my list of.
Could we create like an inactive directory or something, or you know what I mean?
Yeah.
Just move them
Have to
into
be
an
outside the
inactive.
plugin
And,
section.
yeah, so ATS has like a plugin / experimental and plugin / this, and experimental doesn't get built normally, but
Yeah.
the other one does. Maybe we do.
Yeah,
something
and we
like
could do that. There's a lot of ways to do it. Again, it's just a question of the constraints of the compiler. Again, it's implicitly compiled, so you have to rename the file or add some kind of code that says don't initialize this.
Because
But we
especially
could
with the
do
endpoint
it.
ones, you may not want those endpoints, right? Or maybe you have your version of
Yeah.
ASATs and somebody else has another one.
Yeah, and again, my initial thought had been just to comment them out, but we could come up with something more complex if we need like a list or
Yeah.
something.
I think we wanted to think about that.
Sure. So, yeah, just moving on. Again, there's a prototype disk cache. I was just going to have this a single line somewhere, but there's just too much to address. So this is it. It's 5 bullet points. It's completely untested. I did this over a weekend. I just want to mention, somebody says I need disk or whatever. Completely untested. We have not done any kind of testing. I've made some curls when I was writing it. It's a single file B tree. So it's a B tree, a B plus tree, sorry. But it's a single file, kind of like SQLite. It's an existing library. That's the second dependency I mentioned. Grove uses a cache interface. Like I said earlier, caches can be plugged in. They just have to fulfill the interface. So this fulfills the interface. And there's actually 2 extra layers to it. Disk cache is not really practically usable without a memory cache in front of it. So there's a tier cache that again fulfills that interface and puts a memory cache in front of the disk cache. And then there's a multi-disk cache that also fulfills the interface, sits in front of both of those, and consistent hashes to multiple files. So for example, most of our servers, most of our edge caches have like 20-something drives, multiple disk caches. And most people are probably going to have more than one hard drive. And so with a file-based database, that you have to make multiple files. And so there's a multi-cache that, again, consistent hashes. So you can put a file on each disk and use that. Or maybe for performance, maybe you need 100 files on each disk. Again, it's not tested, but if you absolutely need disk, it's there and you can play with it. So just thinking about future work, we've mentioned a lot of things already that are good ideas. Like I said before, I think we need to write more plugins, more plugin hooks, more data in the objects given to plugins. Again, we're planning on doing more performance testing. We've tested it to saturated 20 gig NIC, but we want to test above and beyond that and see what it can actually do. Again, the disk cache is a total prototype. There's absolutely no way a B plus tree performs as well as the cyclone buffer on a magnetic disk. But maybe we want something that does, or maybe it's good enough, so we can do more testing with that. Like we said earlier, range requests could be a great feature to add. Doing it really well is probably hard. Doing simple stuff to start is probably not too hard. In-place upgrades, another thing I think would be really great to have. The cache is what makes it hard, right? So being able to upgrade in place to swap binaries while keeping the cache, right? So it's not terribly hard to listen on multiple ports in Linux. You set the socket flag, SO use port, and you can bring up a second thing listening on the same one and stop the first one. The problem with that is we need to somehow transfer that memory cache, or that's the big benefit, right? Is to transfer that memory cache while you upgrade and to keep serving.
I think
not
it's
just
more important that you keep the connections open than that you keep the cache. Again,
I would agree. So we could,
You gotta focus on the simple use case
Yes.
and not try and get tempted to figure out the larger
Yes,
use case,
I
right?
would agree. But it just hasn't been a priority for us, so we haven't done
but
either.
I think that's something
But-
we definitely want to do. We want to be able to keep all these
Yeah.
these linear clients, keep them connected, keep serving them, and do an upgrade
Oh.
of the software.
Yeah, and I've got ideas for it. Like we can serialize the cache to disk, so we could have some kind of flag to set to say serialize your thing to disk. Everything is a pointer and a map, so it should be pretty easy, a pretty quick lock to lock that map and get all of the pointers. And then the actual cache objects are never mutated, so we can, in a thread-safe way, we can serialize those to disk and then re-serialize them from disk into memory of the other cache in some kind of balance. We could also use shared memory. So there are ideas, or like you said, if it's okay with dumping the cache, it's pretty easy to do a SO use port. Yeah. Did you have a question?
Any plans to add HTTPS or HTTPS?
Sorry, that should have been in the list. It supports HTTPS. It supports H2 implicitly. We mostly get that for free with Go. So the stat stuff actually has to do some low-level hooks. Go does not want to let you count connection bytes, and we really need an accurate byte count. And so we had to kind of hack into that, and it broke H2 for a while because Go doesn't like you hacking under the hood. But we fixed it. H2 works. I would say H2 doesn't give us as accurate a byte count just because of the way it works. Right, so H2 has all these streams, and they're not really associated with requests, and Go certainly. So in theory, you could associate each event in the stream with the connection. Go doesn't do that. It doesn't give us that association, so we can't actually count bytes with each remap rule / request for each thing sent on the actual connection with H2. So we can count the bytes we send, but it's a little bit less accurate. I haven't seen a great solution to that. I'm not happy with it.
Do you bill like per gigabit per second or per data delivered?
I don't know what our billing is.
So that's why that has to be.
And it's fairly accurate. So again, with H2, we just have to count the bytes in the handler itself. We say we sent this many bytes, and it's just, you know, if there's SSL, maybe that byte is a little bit different. Gzip we can count before, obviously, but anything between us and the connection.
And we do have
be a
it
little
running
off.
with, you know, hundreds of certificates and serving all these, all that stuff.
Yeah, it's got multiple certificates.
Yeah,
We
all
just
that
register.
stuff. We're trying
Um,
different.
What about testing, unit testing? Is that been applied here?
It has the tests that it needed. So I wrote tests as I needed them. It's not doing test-driven development. It doesn't have unit tests for every function. It has tests where they were, again, where I thought they were necessary, and they were necessary at the time to verify things. So it tests all of the rules, all of the RFC 7234 rules. There are tests for that. There are tests for, I don't remember what else, the cache behavior. It doesn't have integration tests. That's another thing that's been on the list and just never been a high enough priority. There's always something more important. I agree 100% it needs integration tests. And if somebody else wants to write them, that would be great. You know, it's going to be open source. But I agree it needs integration tests. We should have integration tests at the high level that verify the behavior, that verify those rules. Again, I wrote unit tests for those rules, for all the RFC 7234 rules. But we should verify those at the high level and say, you know, when I make an external request, is this conforming to the caching rules? Because, those are really important. Early on in the development, there were several things that were missed or not quite working right, and it wreaks havoc on a CDN when your RFC rules aren't what they're supposed to be for cache control.
I think we should do that for origins as well. Have a certification to say, does your origin get all these constraints, if you will, or RFC compliance to ensure that before you come in behind the CDN, we don't have to fight you.
Yeah, I think that's a great idea. Yeah.
Was there any thought to put this as a sidecar of APS
How do you
on
mean?
the same machine, right?
Well, for what purpose?
For linear, for example, instead of having this to have all the support for APS, that you could actually run on the same machine as APS, but you could just forward to it, right? It'd be like a reverse proxy on the same machine.
It occurred to us. I don't think we put a lot of thought into that. Our plan is just to deploy it by itself on machines.
Okay.
What do you
And I'm
think,
assuming
Jan?
this is serving a purpose, right? Then I don't know what you guys observe with linear streaming and APS.
So
This just to kind of be like lighter weight.
I don't think that would be any more difficult than you would imagine, right? So it's not trivial. You want to serve two things on port 80. You'd have to set a proxy.
APS is actually proxy to this one, right? So you could run
Yeah.
or in the background.
You could do it either way. You could make this proxy to ATS too. So it would be as difficult as you think. It shouldn't be any more difficult than the obvious.
Should be a standard config, but running in the cache.
Sure.
And it may be useful. I mean, ATS, we do a lot of stupid stuff, right? We have this RAM cache on the RAM drive,
Exactly.
and
That's
then
why.
we have the RAM cache in front of it, and it's like, it's got to be in RAM at least 4 times.
Yeah.
And
Well, yeah, the RAM cache, I mean, it's not so bad because it only allocates like a smaller portion or linear.
But it's inefficient what we do with ATS. And
Right,
we're
oh,
kind of just making it go away with performance. but
Doesn't
is
it do the whole cycling buffer too?
Yeah,
Which that's got to
which
be
is
less
kinda-
efficient than
yeah.
a direct lookup in memory. That is. Yeah. Any other questions?
No? When can we test it?
It's open source.
Right
I think it should have been upside down.
No.
now.
Wow, I dropped it.
Wow.
So yeah,
that's
go-
what the,
Go play with it. It's a pull request. It's 2165.
You said 6,000 lines of code. That's 25,000.
Yeah.
What do you
It's
say?
from vendor
Oh,
and stuff.
vendor.
Uh,
Yeah, it's vendor.
Yeah. And
We know how Jan feels about vendoring.
vendoring is stupid.
I think it is an evil that
Let's
is
not
lesser.
talk about it.
lesser-
Let's not talk about it. I'm
Yes.
feeling good. I don't want to talk about it. I'm going to merge that.
So yeah, it's here. No, don't merge it. So I had to do this real quick last night. It doesn't have history. I would like to go through the Git pane to get history from the other repository. So don't merge it. But if anyone wants to look at the code, it's there, and you can play with it. You can download it. You can install it. You can run it. I will try to fix the history within the week, and we can actually merge it.
So why do you want to fix the history? Isn't there some Comcast specific shit we didn't want to get in there?
Well, and that was part of. I was going to look into that, and if there wasn't, it would be great to have the history. Do you think we have anything we can't expose?
I don't know.
I don't think there's anything that would be a bad. Like we have the Roku stuff, but does anybody
the
care?
Roku, there's the Roku stuff.
Does it matter
There
if
was
people
some,
see that?
Comcast header shit that we just fixed. There was like Comcast IP addresses and stuff in there that were in an example log line.
Yeah.
That just got fixed.
If that's an issue, we can not. It'd be nice to have the history.
I don't really care.
Either way, the code's there. So if anyone wants to play with it now, it's
So
there.
can I do my pull request? Because you didn't merge my pull request, did you?
No,
I'm gonna keep dogging you, man.
I'll get to it. So yeah, any other questions?
Well, now it grows in production. You can just go ask Steve, and Steve will just murder me.
That is the version.
All right, thanks, Ron. What do we got next, Steve? Yeah, I think so.